What's up, Nico? That is almost irrelevant, for at least what you're doing right now. But if you really want me to answer, um, angular speed, that's W. You don't need to know this. And then circular velocity is no. Yes. Okay, we'll get started in probably like 2 minutes. So just be patient. If you haven't kind of looked at this in the last couple of days, I suggest you actually do that. You can find this in the topic section and on campus. And then you should also have, well, most of you have a like a physical handout of it. All right, so before we actually start to do this, kind of have it out in front of you. Maybe think about them for a little bit. And then even if you wanted to, well, not even, just as like a upfront kind of a thing, um, just watching this as your study probably isn't enough. Okay, this is a great like last minute thing that's fine, but like at some point you're gonna have to do these questions kind of on your own, right? Just like I said last time in class. So just keep that in mind. We'll go over the rules and stuff that you need to know, but you're not going to have those rules like right in front of you when you're actually taking the test. All right. Okay. So really quickly, um, before we actually do all these questions, just so you guys have it out in front of you again, so you see it one more time. Some things that we absolutely need to know is that there are two kind of different sides of the coin that we're working with, right? Before all this, we had worked with exponential. And then in this chapter, we started working with logarithms. All right. These two things undo one another. All right. So if you ever kind of see something like this or like this in number 1 and 2, you want to undo those exponential functions, right? So you want to undo this 15 to some power or this 5 to some power. Okay. So in order to undo those, you need to use a logarithm. So that's kind of the first and best thing that you can really do, is to just kind of think out what you actually need to do in terms of these two things, right? Now, in an exponential, if we have a to some power b, and that's equal to c, right? That says the exact same thing as log base a of c is equal to b. Okay, these they mean the same thing, but they're asking different questions, right? This left-hand side, this is asking a to some power is what, right? So it's asking what is our actual result of taking a to that power. This right-hand side is asking a to what power is c, right? So we're asking, two different things. You can't see that because it's dark on the back. That's fine. So again, that's just the placement, right? There's no actual math done. It's just kind of a definition. Okay. And then from those, right, because these two things mean the exact same thing, we get kind of the list of properties that we need to know. And I'm not going to go over the exponential ones, but right, there's some good logs that we need to know, right? So log base A of 0, not 0, log base A of 1, that's going to equal 0, right? Because A to the 0 power is 1. Log base A of A is going to equal 1 because A to the first power is 1. And then there's the one-to-one property, which kind of goes with the exponential property, or the exponential kind of part of this. And that says if log base A of x is equal to log base A of y, then x is equal to y. So what this means is that it's just, if you have the same thing on both sides, like log base A and log base A, or log base 7 and log base 7 on both sides, or ln or log or whatever, if those two things match up, you can literally just get rid of them. And the same thing works for exponentials. Okay, so if you have some power to the x, or some base to the x power is equal some base to the y power, then it's the same story, right? Then x is equal to y. Okay, and the only other thing that's kind of crucial that we know is the inverse property. And what that says, and this kind of goes along with the power property, so we'll kind of cross that bridge when we get there. But if we have log base A of A to some power, these A's, right, this log base A and this A, those are inverses, right? Log base A and A to the power of x, those two things are opposites, as we set up here. Not opposites, inverses. Okay, so they undo one another, and what you're left with is just x. Okay, and the same is true for exponentials, right? So if we have A to the power of log base A of something, we're just going to be left with that something, right? Because A to the power of something and log base A, those are inverses. So we're just left with that something, that x. Okay, so that's kind of the basic stuff. These are absolutely things that you need to know, and we'll kind of get to the expanding and condensing properties here in a second. But these things, if you understand these things, you can actually derive pretty much everything else. Okay, so going on from that, let's just go ahead and kind of jump right in with number 1 and 2. Okay, solve each equation. And there are kind of two different ways you can do this. You can try and find the same base on both sides and then use the one-to-one property. Right, so you can get, the same A on both sides and then set the exponents equal to one another. Sometimes that doesn't work, in which case you need to use logs. Okay, and I'll show you what that looks like here in a second. But let's start with number 1. Okay, the first thing I look at when I see these is the two bases, right? So we have base 5 and base 1. And then I ask myself, is there any way to write those things in the same base? And there is, if you understand exactly, or you understand those properties of exponents. Okay, so we can rewrite 1 as 5 to the power of 0, right? Anything to the power of 0 is always going to be 1. Okay, so that's how to rewrite 1 with a base of 5. And then once we have that, okay, we have base 5 on both sides, so we can just set those exponents equal to one another. And then all we have to do is solve. Okay, so then b is equal to -1. Okay, you don't have to do it this way. That's just the way I would do it because that seems the easiest. But you can actually, we can cancel out this 5 by taking log base 5 on both sides. And we're going to get the same answer. So in order to cancel this out, I'm just going to do this a separate way just so you can see it. We can take log base 5 of both sides. Right, so those things in parentheses, that's what we originally had. And then the two log base 5s are a function I'm kind of putting on top of that. And what that does is it cancels out this 5 and log base 5, and we're just left with -2b minus 2. Okay, then we can think about this property over here and know that that right-hand side is equal to 0, and we're going to get the same answer. Okay, so either one of these ways, it's kind of up to you what you feel comfortable with. I will say that you can't use this one on number 2. It's a little bit harder. You might be able to, but in terms of integers and stuff that you guys know, you probably can't. Okay. Number 2. There are 2 things here. There's this term, and then there's this 4. The first thing we need to do is get rid of anything not attached to that 2r. Okay, and the only thing not attached to that is 4, so we can subtract that from both sides, and we get 15 to the negative 2r is equal to 61. Then what you could do is you could ask yourself if there's a common base between 15 and 61. There's not. You could try 3, you could try 5, and really 15 is not, it's not prime, but there's no perfect squares of 15. So that nothing really works, okay? So then what do? Well, in order to cancel out a base, right, in order to cancel out this base, so we get negative 2r on its own, we take the log base of 15 on both sides. And then we can use that inverse property, right? So log base 15 of 15, those 2 things cancel. We're left with negative 2r, and nothing happens on the right. That log base 15 just stays there because there's nothing to cancel. And then we divide everything by 2. And then this is our answer. And I'm not worried about decimals. This is actually a more precise answer than anything you'd get in a calculator. So let's stick with this. Okay. Keep in mind, this step, like getting this step up to this step, is the hard part. Everything else is just algebra. And I realize you can't see the bottom. This stuff. My bad. That's the inverse property. Right, log base a of a to the x, that's just equal to x. A to the power of log base a of x is equal to x. Right, these 2 things undo one another. These 2 things undo one another. Okay, so then we get to expanding and condensing, and really quickly expanding. So, couple properties. Right, the product property, which says that if you have the product of 2 things inside parentheses, you can split that up into 2 different logs, into the sum of 2 different logs. Okay, so product means add in between. Okay, some people were confusing that just a little bit in class over the last week. Let's try not to do that. Okay, the other property is the quotient property, which says that if you have a fraction or a ratio of 2 things, we can rewrite this as a log, as the difference of the logs of those 2 things. Okay, we went over in class kind of why this works. It has to do with, properties of exponents, but this is the rule that we need to know. Okay, and then the last one is the power property. Okay, so if we have log base a of x to some power, let's say b, we can take this b and put it out front, and then that's expanded. Okay, now all these properties work in both directions. Okay, so we can go from right to left or left to right. So on number 3, we have log base 7 of x squared over y to the 6. And the first thing that you should notice is the fraction bar. Right, we have something over something else, which means we can use this property first. And when we do that, we get log base 7 of x squared minus log base 7 of y to the 6th. So that's the first step. Okay, so that's like part 1 of this problem. Part 2 is taking each of these as their own problem. Okay, and you should notice that there are 2 exponents here, which you need to put out front. All right, so then we're going to be using this property. So when we do that, we get 2 log base 7 of x minus 6 log base 7 of y. Okay, and again, if you're having questions over any of this stuff, ask. I'm kind of taking a look over if anyone does, or email me, up to you. Okay, but we'll move on. All right, so the next one is working from right to left this time. Okay, so from those equations that you saw above, we're going to work the opposite way. Okay, so the first thing we need to do is we need to take each of these as their own problem. Let's do red, blue, and then this weird purple. All right, so each of those let's treat as their own problem. The red part, nothing happens. There's no exponent. There's no, like fraction inside or whatever. This just stays the same. Okay, this blue part is really being multiplied by 1/2. Okay, so I'm going to write it over here. What this is actually saying is this 1/2 times log base 4 of u. So this 1/2, right, whenever you see something in front of a log, that means it goes back in the exponent of the thing inside, right? So we can rewrite this as log base 4 of u to the 1/2, and then that's as condensed as that can get. Okay, and then the same thing is true for that part in purple. Okay, that's exactly the same thing. We can rewrite that as 1/2 log base 4 of v. This 1/2 becomes an exponent of that v. Okay, so that's using the power property, right? So we're using this property, but backwards, right? So we saw something in front of the log. Oops. We saw something in front of the log, and then that became the exponent on the left-hand side. Okay, so again, that's kind of like part 1. All right, part 2 is then realizing that we're adding all of these things together, and because we're adding those things and they all have the same base, that means we can condense them into a log of products, right? So our final answer is just going to be log base 4 of the product of each of these things, right? So w times u to the 1/2 times v to the 1/2. And then that is as condensed as that's going to get. So that's condensing and expanding. All right, so we need to know these rules right here. And there's there's not a ton of math in that. It's just a lot of rearranging. Okay, so then we get to solving. Okay, which is actually, I think, the hardest probably on here. Yes, except for maybe 11 and 12. Okay, but this is kind of combining things that we just did. So the first thing you need to ask yourself is where's like our unknown. In number 5, our unknown is attached to the 10. which is actually inside this log base 3. And we need to get rid of everything that's not attached to that. Okay, so we need to add over the 6 to both sides. And when we do that, we get negative 5 plus 6, which is just 1. Okay, and then we need to undo that log. There's actually 2 different ways you could do it. One, well, I'll do like the normal way that I would normally explain. In order to undo this log, right, we have to take the inverse of that log, which is an exponential. Okay, so really what we're doing is we're having the base of 3, right, which we get from right here. And everything else is an exponent. So again, this 3 and this 3 come from that exponent, right? And then when we do that, these things cancel. We're left with negative 10x is equal to 3. Sorry, is equal to 3. Yes. Okay, and then x is equal to negative 3/10. Another thing you could do is once you get to this point, you can understand that 3... No, never mind. Ignore that. I thought that was a 0. Yeah, so this is the way I would do it. Okay. So moving on to number 6. I don't know why I'm tripping up on number 5. Same thing, right? So we get rid of everything that's not attached inside the log. So we get log base 9 of negative 6x minus 7 is equal to 6. Card right side. That should be equal to negative 2. And then we need to cancel out that base of 9. So again, we use that base as a base of everything else. So again, we take this and put them as bases of everything else as an exponent. Okay, that cancels out the log base 9. We get negative 6x minus 7 is equal to 1. Actually, I'm just going to leave this as 9 to the negative 2. Why is it negative 2? If we subtract 8 from both sides, 6 minus 8 is negative 2. Right, so if I add that step, minus 8, 6 minus 8 is negative 2. And then we just work from here, right? So we add 7. So we have negative 6x is equal 9 to the negative 2 plus 7. And if people are confused about this 9 to the negative 2, honestly, it's fine if you have that. It's actually probably going to make your life a lot easier, which I think I said in class. And I really just don't feel like dealing with fractions right now, because this ends up being 1 over 81. And that just, it makes things a little bit more difficult than it needs to be. Okay, and then we divide everything by negative 6. And when we do that, we get 9 to the negative 2 plus 7, all divided by negative 6. So then this is our answer. If you wanted to go further than that, like if you wanted to simplify that 9 to the negative 2, go for it. You're just adding work on that you don't need. But that's up to you. Okay, then we have number 7. And number 7 is definitely the hardest one in here. You know what? Actually, it's not. I take that back. It's the hardest one of these 3 for sure, but it's actually a lot easier than what I thought it just was. All right, so the first thing we do is we kind of just take a look at the overall problem. You should notice that there's an ln here and an ln here, and then later it'll be important that there's also an ln here, okay? ln means natural log. So if you wanted to rewrite this entire problem as log base e of 4 minus log base e of negative x is equal to log base e of 48, that's not a bad thing. If that makes you more comfortable, go for it. Some people tend to freak out about this new notation. It just means this, okay? So what after that, you should notice that, again, same base, and they're being subtracted. So we should notice this subtraction sign, okay? And because we're subtracting logs with the same base, we can actually combine them in a quotient. So this left-hand side becomes log base e of 4 divided by negative x is just equal to the right-hand side. That is using that condensing that we did up above. Okay, so subtraction means quotient, right? And then from there, we have a log base e on the left and a log base e on the right, and there's nothing else. Okay, so because of that, we can use that one-to-one property, which basically just means that we can cancel these two logs and just solve as is. So 4 divided by negative x is equal to 48. So then x, well, I'll kind of do this step by step. I would multiply, actually, you could just flip everything upside down. So negative x over 4 is equal to 1 over 48. So x is then equal to negative 4 over 48. Okay, so all I did is take the reciprocal of both sides. So 4 over negative x becomes negative x over 4. 48 becomes 1 over 48. And then you solve that way. You could also just multiply by x on both sides and then divide by 48. It's up to you. Okay, but that part is purely algebra, right? So if I need to go back there, I can. I understand that that part's a little bit confusing. Okay, so that's kind of the solving part. At least that's the easier part of the solving parts. So then we get to number 8. And on number 8 is actually kind of like if you just rewrite it, it should be a little bit obvious. This here, log base 5 of 125, is asking what power of 5 is 125. Right, so 5 to some power is equal to 125. And you could do this just by kind of guess and check, right? So 5 times 5. I'm going to do this in a different color so we can kind of see what's happening. Hijack height. So 5 times 5, that's equal to 25. So that's 5 squared. 5 squared times 5, that's equal to 125, which is equal to 5 cubed. Okay, so that's our answer to this. That's just the number 3. So this whole thing is just equal to 3. Okay, you could also just divide 125 by 5 a bunch of times and see how many times you get. All right, so that's one factor of 125. Then we would divide 25 by 5. We get 5 again. And then 5 divided by 5. That's just 1, so 3 times. Okay. This long division is probably a little bit more confusing. I would tend to think of it like this. It'll be something relatively easy. Powers of 4, 5, 2, or 3. I don't see myself going higher than that. Okay. And then actually, number 8 is harder than number 9 because number 9 actually kind of gives you the answer already. Up above, like way up above, way earlier, I explained the definition of log, right? So log base a of x is equal to b means the same thing as a to the power of b is equal to x. Okay, so all we're doing for number 9 is just rearranging like that. So we want to rewrite the logarithmic form into exponential, right? So this is our base. That's the big number. This is our exponent. And then this 225, that's kind of like our answer. So all we're doing here is rearranging. Okay, so nothing huge. And then we're working the opposite way in number 10. Okay, so we're working right to left now instead of left to right. Okay, so 8 is our base. So we have log base 8. 64 is what's inside. And then 2 is on the right-hand side. So again, 8 to some power is 64. That power is 2. Okay, so number 9 and number 10 should be fairly easy and straightforward problems, so long as you know this thing right here. Okay, so on to number 11, which is actually similar to questions we did before, to these guys. Okay, but number 11 says solve each equation. We have e to the 3x is equal to 9. Sorry, minus 9 is equal to 19. And the process is the same, right? So we want to get rid of everything not attached to this 3x. So we need to get rid of that negative 9. If we add 9 on both sides, we get e to the 3x is equal to 28. And then again, we're doing the same thing. We need to cancel out this, or we need to undo this exponential. In order to undo exponentials, we use logarithms. So in this case, we want to use log base e on both sides. Okay, this also means we're taking the natural log on both sides. You can write it either one of these two ways. Okay, they both mean the same thing. And when we do that, this log base e and this e cancel, and then the right-hand side just stays the same. Okay, so then we're left with 3x is equal to, I'm going to use ln in this case, ln of 28. Divide by 3 on both sides, we get ln of 28 divided by 3. Okay, got a couple more. Actually, we got 2 more. I'm gonna leave I'm gonna leave 14 alone because I want to see who can actually do it. Again, that's bonus. That'll make up for missing points. But number 12 and 13 we'll definitely do. All right. So number 12 kind of combines a couple of things that we did before. Again, okay. And the first thing we need to notice is that there are 2 logs with the same base, and they are being separated by a subtraction sign. When that happens, we can combine those 2 things. So we should get the quotient of x squared minus 6 and 8. And that should be equal to 1. And then we need to cancel out that log base 9. So we take this 9 as a base of everything that you see. Right, so 9 to the power of everything in blue. And what that does is on the left-hand side, it cancels out the log base 9. So then if I move up here, we get x squared minus 6 over 8 is equal to 9 multiplied by 8 on both sides. x squared minus 6 is equal to 72. Subtract by 6, or add 6, sorry. So 72 is equal to, or x squared is equal to 78. And then x is equal to the square root of 78. Okay. After this step, everything is algebra, which is why I kind of went through it really quickly. But I'll let you look at that for a second. We'll finish that last problem, and then I'll take any questions you have. Okay. Again, I'll scroll through this quickly after this, but let's finish this with number 13. Again, there is going to be a number 14, but that's all going to be a bonus. So I'm not going to do that here. This exactly will maybe not exactly. I might change a couple of numbers here, but this will show up on the actual test. Okay, so number 13, change the base of ln4 into a quotient of 2 base 7 logarithms. Okay, so we want to make this logarithm into a quotient of 2 log base 7 logarithms. So, like I said before, we can rewrite ln of 4 as log base e of 4, right? These mean the same thing. This thing inside parentheses goes up top. And then this base goes down bottom. And then we're done. That's it. Okay, so there's not a whole lot to change the base formula. The thing inside parentheses goes up top. The thing that's the base goes down bottom. And then you have your new base, log base, on both the top and bottom. Okay, so I'm going to quickly kind of scroll back up. I'll scroll down as we go. And then probably in the next 10 or so minutes, unless people have questions, on 13, why is E instead of 2? On 13, why is it E instead of 2? So ln, again, ln means natural log. What this means is that we have log base e of 4. Okay. And that's why, right? So if we want to change this log base e of 4 into log base 7, we have to take our 4 up top and then our e down bottom. All right, so there's no 2 involved. I hope that answers your question. I'm not entirely sure. Okay, so I'm going to scroll up and kind of quickly scroll down. I get that there's that hockey game happening. Okay, perfect. So I'll put myself on mute and just kind of make sure no one has questions, and then that is the practice test. Okay, and you guys probably in the next hour or so this will actually be up so you can scroll through it. I'm hoping you're not studying super late on this, um, but it'll be there for you. So we don't need to worry about 14. You don't have to worry about it. It's a bonus. Um, kind of just want to see if anyone can do it, to be honest. That's all. No, it's not going to count for your total test. Okay, so seniors who are still here, um, if you have other questions, feel free to email me. This video will be up probably in about an hour. I'm going to do a couple of questions for juniors after this, um, but hopefully after that it won't take very long for this video to be up. All right. Um, I also have a study hall during period 7. I'll be in the cafe, so if you have questions then, feel free to kind of go down there and just ask. Um, it doesn't have to be anything formal. Just come on down. Um, I'm actually sure what period is first tomorrow, so I can't exactly tell you where I'm going to be at. Well, it's 2 today, so it would be 6 tomorrow, which means I'm going to be teaching a class. Okay, so from 8:30 to 9 o'clock, I will be in room 306. Yeah. But I'll also be helping out with juniors because they got a quiz tomorrow too. Okay. So it's going to be a little bit hectic in the morning. So I would prefer that you email me and I'll try and answer as best I can before your class tomorrow. Um, if you want to come in before 8:30, that's fine. Just let me know. Uh, and then period 7 in the cafe. All right. So that is the practice test. Again, this will be available here in probably the next hour. So if you have questions, you can consult that. You can email me. And like I said, I'll do my best to kind of respond. All right. So that's all I've got for seniors. Um, and then probably in the next like 5 to 10 minutes, I'll start with juniors. All right. Connor, if you're still here, I don't actually know the right number. I just know it by the fraction of the log and the other stuff. Okay. Um, yeah, I'm not sure off the top of my head. Looks like you have like units right. Um, but I'm also not going to tell you what's right or wrong because that's also going to show up on the test. All right. So just hold on to that. Show me your work tomorrow, and then we'll go from there. Okay. Um, Juniors, who I'm hoping are starting to come in here. Yeah. Give me like 2 or 3 minutes. I'm gonna get a drink of water, write out some identities, and maybe it'll give people enough time to watch if they're wanting to. So junior start, we'll say 8:35. 25, not 35. Okay. So this is what we're going over. Or we're going over these identities, and ideally, you have these memorized. You should be able to write down these pretty much no problem by tomorrow. Okay. And I know that seems like a lot to ask, and I want to make sure that I have these written right. Yes. Okay, great. So again, ideally you kind of have these in the back of your head whenever you're doing these trig identity stuff and proving different equalities. Okay. So I want to go over just a couple of these. I don't think we're going to be able to go over every single one, but hopefully, I'll pick out 3 or 4, and then if you guys have questions on others, I'll go over that too. That's fine. So let's start. Let's start on number 4. Okay, and I'm just gonna pick a random place. So again, if you have like a quick one, like you actually totally want, just comment, and I'll go right to that one. All right. So from these trig identities, these are all like these all work. Okay, and we're trying to get things to look like these, so we can cancel out common factors, so we can set a bunch of stuff equal to 1. Or so we can get it to look at the right hand side, right? So that's our goal. So number 4, we can do this in a number of ways, right? I am always going to start on the left, just because that's kind of how I was taught, I guess, or that's how I've always done it. So I'm just going to do that, all right? And it's probably actually easier to start on the right, but that's okay. All right, so I'm going to rewrite tangent squared as sine squared over cosine squared. And then I'm going to rewrite, over the secant as 1 over secant squared. Okay. Then I can rewrite 1 over secant squared as just cosine squared. So then we have this. You should notice that these two cosines cancel, and we're left with sine squared of x over 1. Okay, so kind of a different, normally you see cosine squared plus sine squared is equal to 1, and then you set that equal to 1. Normally you don't see 1 and then set that equal to cosine squared plus sine squared, but in this case that's what you do. Okay, so sine squared remains up top. We know from our identities that 1 is also equal to cosine squared plus sine squared. And I'm going to kind of stop right there real quick. And I mentioned this to my seniors. Make sure, like, you watching me do this stuff shouldn't be like your only study method tonight. Okay? What I would recommend is you watch me go through this a couple times, maybe look at the identities, make sure those are memorized, but also to actually like try a couple of these problems. And if you don't get them right, that's okay. Like, come in, we can have 20 minutes before class and we can go over a couple of these. That's no problem. All right, so again, you watching me do this stuff shouldn't be your only preparation. All right, so that's number 4, right? We got that the left-hand side, we manipulated that a bunch and we got it equal to the right-hand side, so then we're done. All right, so that's number 4. My guess is that no one has anyone specific, so I'll just kind of look for a good one. That looks fun. All right, let's do that. Let's do number 6. Yeah, let's do number 6. Okay. All right, I'm going to do my method, and we're going to add fractions. So I'm going to start on the right again, or start on the left. It'd probably be easier if I start on the right. Whatever. Cotangent, right? This cotangent, that's equal to cosine over sine. Then we have plus cosine over 1 all over cotangent, which is equal to cosine over sine again. This part will come in handy later, at least I think. Okay, so I haven't actually written this one out yet. In order to add these two things, we need a common denominator. Okay, so I'm going to multiply this right-hand side of this numerator by sine over sine. And when we do that, we still have cosine over sine on the left. And then we have cosine times sine. Over sine. So you can't cancel out cotangent when it's in the form of x plus y over x. No. Yeah, you cannot do that. And I keep seeing that, and that you can't do that. Cotangent here is not a common factor of the entire numerator. Okay, if it was a common factor, that's one thing. But it is just like if you're taking the sum of things, that's not a common factor. Okay, so which makes this harder. Okay, if that were the case, it wouldn't make sense. But that's all right. Okay, so then we have this, all right, and I'm hoping we kind of follow. All I did was rewrite cotangent as cosine over sine. All right, that's this step. I don't think you can see my mouse on this. I should probably change that at some point, but that's all right. And then cosine over 1. In order to add these two things together, we have to get a common denominator. I chose that denominator as sine because it's already over here. Right here. Okay. And then we get to add those two things together. No. There we go. What about the first term? What do you mean, James? Cosine over sine times sine over sine. No, we don't need a common denominator here because it's already there. That denominator is already sine. Okay, so picture multiplying or adding 4/3 plus 5 over 1. Okay, we don't need to multiply this by 1 over 1. I guess we could, but the common denominator here is 3. So we'd really need to multiply this side by 3 over 3. Kind of the same thing, right? Except sine is 3 in this case, and 5 is cosine. Okay, so then we get this. I'll say this now that we're more than halfway through the problem. I'm probably not doing this the easiest way. This is just how I'm doing it because this is the thing that seems the easiest. It's probably not. Okay, there are different ways to do this. All right. So then I'm going to do probably 2 steps in one. I'm going to just go ahead and tell you that this can be factored as cosine of x times 1 plus sine x. Okay, and then we'd multiply that by the reciprocal of this guy, because when we're dividing by a fraction, we're really multiplying by the denominator. And I'm going to do that over here, right? So what we do, we have cosine of x times 1 plus sine of x over sine x. And we're multiplying that by the reciprocal of that denominator, which is sine of x over cosine x. Yes. And then we can cancel out this sine x and that sine x. And then we have cosine of x. Can I explain how I simplified the numerator? Yeah. So there's a cosine in this term, and there's a cosine in this second term. All we did was factor that cosine out, right? So that cosine comes here, and then when we factor that, it becomes 1 plus sine x. So what I'm doing here, think if we have x plus xy, we can factor out the x, and that becomes 1 plus y. That's basically what we're doing. So then we get this part in white. I'm hoping what I said up there makes sense. And I think that's what you were asking. All right. Once we do that, we can cross these guys out. And we are left with just 1 plus sine x. I will try and not give you something this hard. I just picked this because it was really hard, and I wanted to see if I could do it. So don't panic. This is just a good exercise in, manipulation. All right. Now I'm gonna do something which seems stupid. All right, and that has to do with this 1. This 1 can be written a lot of different ways. One way has to do with this guy. So if we subtract over that tangent squared, we get 1 is equal to secant squared minus tangent squared. So we can rewrite that as secant squared of x minus tangent squared of x plus sine. And that's our answer. It was easier the other way. Yeah, I know. I probably did this the right. Yeah, you could work on the right hand side, and it's probably a whole lot easier. I was just able to start watching. Will this live stream be posted to watch it back? Yeah, it might take a little bit to be here. Actually, if you stay on here, you should be able to rewind. So when this ends, just don't close the tab, and you can scroll freely. Okay. So once we get down here, I'm gonna say this again. This is not a type of question that I would expect you to be able to do. Yeah, this is a longer problem. Okay, number 7 though, that should be easy enough. All right, but just to make this obvious that that's our answer, we can rearrange these two terms, this term and this term, and we get negative tangent plus secant squared plus sine. And we can put that out front. And we have our answer. So again, that is how you would do this problem. That's how I would do this problem. There's probably an easier way. I would guess it's easier to work back from this. Okay. Yeah, because there's a cotangent over cotangent at some point. Okay. So that's number 6. Again, don't panic over that. Let's do number 7 just as a little bit easier. And then we'll go on to your questions. All right. I'm going to work on the right this time. So I'm working with this guy. Just kidding. I'm working on the left. All right, 1 over cosecant squared, that's the same as 1 over sine squared. Secant squared is 1 over cosine squared. And that's all we've done so far. Okay. Cosecant is 1 over sine squared. Secant squared is 1 over cosine squared. Again, we have to add these two things together. So in order to do that, we got to get a common denominator. All right. In this case, I would multiply by sine squared on the right, cosine squared on the left. And that way our common denominator is sine times cosine. Squared. Both of them are squared. I'm hoping we understand that part. Again, if it makes it easier, think about 1/3 plus 1 over like 7. Okay, you'd multiply this by 3 over 3, this by 7 over 7, and you'd get 21 in the denominator. All right, that's all we're doing. So when we do that, we get cosine squared over cosine squared sine squared plus sine squared over cosine squared sine squared. And when we do that, right, because we have that common denominator, we can just add the numerators together and keep the same denominator. Okay, so then we have cosine squared plus sine squared up top, which you should immediately recognize as 1. Okay, then we peek at what we actually want. We want secant and up top and sine down bottom. Sine's already down bottom. And we can take this cosine, move it up top, and it becomes secant squared. So this just becomes secant squared of x over sine squared of x. And we proved it. Yeah, it's probably easier to do what I just did, actually. Working on the right basically would make you turn this 1 into something, which if you don't choose the right something, then things can go wrong. Choosing the left-hand side in this case is a little bit more direct. Knowing that takes practice. But that's what we're doing. Okay. So I'm going to leave this open. Questions that you want me to do. We'll start there because I just did 2 really hard ones. Or 7 is decently... It's not impossible. Number 6 I wouldn't expect you to do. Number 7, maybe. Can you do one of the factoring ones? Yes. I think you mean the last 3. Oh, no, these. Right? Yeah. Yeah. Okay, great. Let's do number 12. I think we did number 11 in class. So let's do number 12. Or at least I did 11 for someone in class. I don't remember how I did it. Doesn't look that bad. So number 12. We have 2 things, and each is a sum or difference. Okay. So on the left, we just FOIL, right? 1 times 1, 1 times sine, negative sine times 1, and then negative sine times positive sine. Okay, so when we do that, we get 1 plus sine of theta minus sine theta. Are those final 3 going to be on the quiz? Yeah, actually, these should probably be easier than most of the other ones. And you'll see why here in a second. 11 maybe a little bit harder, but not 12 and 13 should be decently easy. So minus sine theta and then plus minus sine theta squared. That's all you have the cosine squared. All right. Now, so that's just foiling. Plus sine, minus sine, those 2 things cancel. And we're left with 1. Oh, not that color. 1 minus sine squared theta. I'm just going to keep the right-hand side here. And this is actually equal to cosine squared theta. Okay, because of our identity, right? Sine squared plus cosine squared is equal to 1. if we subtract sine squared from both sides, we get that, right? So this is equal to cosine squared, which is what we got. Cosine squared is equal to cosine squared. We proved it. Honestly, it's the same thing for number 13. I just used different trig functions. Okay, so you'd FOIL, right? Secant times secant, secant times tangent, tangent times secant, and then tangent times negative tangent. If you do all that stuff, middle terms are going to cancel, right? Kind of like we did right here and right here. And you're just going to be left with the outer two terms. And you can use an identity to simplify that. So you should get secant squared minus tangent squared, which is actually just equal to 1. All right, because you guys should probably know this anyway. So these two things are called conjugates of one another. When you multiply conjugates, and we actually did go over this, but we're not in complex analysis, so we need to do this. You're just left with a minus b squared, a squared minus b squared. Same thing over here, just different trig functions are involved. If we move the sine theta to the right for cosine theta plus sine theta is equal to 1 for our final answer, would you count it wrong? Again, would I count it wrong? No, because it's not. But I do want you to just manipulate one side. So if you pick a side, focus on it. All right. So like I picked the right-hand side. Sorry, the left-hand side. So I just manipulate that. Now, on the right-hand side, if there is an identity, you can use it. But what I don't want is subtraction, addition, or multiplication between sides. Again, that's not wrong. But I want us to get in the habit of, sitting still on one side of the equation. So when I mark it wrong, no. But that's not exactly how I want you to do it. Okay. Again, I'll leave this open to you guys. If you want me to do more, I'll do more. If you don't, that's okay too. Let's do an easier one from up top that I would expect you to be able to do. Like number 1. Actually, a lot of people did number 1 in class. So let's do number 5. Okay, number 5. I immediately see the cosine squared plus sine squared, so I know that's equal to 1. Then we have 1 over cotangent of x. So that's just step 1, which pretty much does it for you. You might not see it just yet, but if you rewrite cotangent as just, or 1 over cotangent as tangent, or just go directly to sine over cosine. All right, so this, you can either go directly there or switch it to tangent first. You're not really skipping steps, you're just moving differently. And then we want sine up top and secant on top. So sine's already up top, cosine in the denominator just becomes secant. And if you really if that confuses you, think of this as sine of x times 1 over cosine of x. 1 over cosine of x is secant, so we have sine x times secant x, and then we're done. This is definitely something like you should be able to do. This was right down the alley of things that I would expect. Okay, so again, I'll leave it open for you guys. If you want me to do another one, just go ahead and tell me, and I will do it. Otherwise, I'll leave this open for a couple minutes and let people ask questions. If there are no questions, I'll end it. So yeah. Yeah, and if you do decide to leave right now, just make sure this isn't your only studying. Make sure those identities are memorized or at least well known, like super well known. And then do a couple problems on your own. Okay, just watching me do this stuff is not necessarily studying. Okay, it might be a good refresher, but it's not really preparation. Or it's not the total preparation. It's part preparation, but not the total thing. Open note, no, I'm sorry. We can do this, I promise. It's not going to be long. It's going to be 2 or 3 questions. And we can review for a little bit up front. That's fine. But we do need to know it. So no cards are great. No cards are perfect for this. But no open notes. Oh, 11. Yeah. Yeah, let me think about this for like 2 seconds. Because I know I definitely did this. Just trying to figure out how. Two seconds. I don't know, Bryce. There's usually one easier one and one harder one. So just be prepared. If you know your identities and try a couple things, that's all I really care about. And I will say, like, the hardest part of some of these is just like picking a spot to start. Okay. That's just manipulating an identity. So if I subtract cosine from both sides in this, we get sine squared is equal to 1 minus cosine squared. And then I can add 1 to, or subtract 1 from both sides. So then we get sine squared of x minus 1 is equal to negative cosine squared. Okay, that part isn't necessarily obvious, but sometimes you have to do it. Okay, so we can rewrite negative cosine squared as this, and that's what I'm going to do. So then we have sine squared of theta minus, plus, right, because that minus is there. Plus sine squared x, theta, whatever, minus 1. And then, if we have one bag of tennis balls, and we add it to another bag of tennis balls, we have 2 bags of tennis balls. And then we're done. But yeah, will something like this be on there? Probably not. Number 12 and 11, or 12 and 13 are definitely fair game. Will those be a harder one? Maybe not. But part of what I'm trying to get you guys to do is to like just pick a spot, use an identity, and just abuse it. And then usually if you do that, something, something cracks here or there, and it works. Like I could have started with sine squared over here. One way I thought about doing this is actually splitting this up into 2 sine squared. Actually, sine squared of theta plus sine squared theta minus 1, and then using one of these in the same way that I did the cosine over there. Okay, so sometimes, again, you got to pick a spot and just go with it. Okay, other questions? Okay, since there are no other questions, I'm going to leave this up for maybe 2 minutes, 2 or 3 minutes. If you have other questions, ask. Otherwise, I'll end that at like 9:08. Okay, so if no one has any questions by 9:08, I'll end this. Again, make sure these identities are known, like, well, okay? These top 6 should be pretty straightforward, right? These bottom 3 are probably the ones that you guys need to really, like, spend some time on, okay? They're intuitive, they make sense, but sometimes they require just a little bit of memorization, which is fine. Yeah, so those are the ones we should be really working on. These top 6, I'm not saying you don't need to know them. You should need to know them. They're just a lot easier to kind of figure out. Okay. Thank you, quality streamer. Thank you, Jesse, quality student. Yep. Email me if you have questions too, and then we can spend time tomorrow morning. All right. Since there are no other questions, I'll end the stream here. Again, if you have other questions, just email me, Teams, chat me, whatever. Uh, or wait until tomorrow morning. It's the first period tomorrow morning, so probably have a little bit more free time. We'll also review just a little bit before the actual quiz. And the quiz it's not going to be like a 10 question quiz. It's going to be like 2 or 3. All right. One decently easy, one medium, and probably one harder. Doable, but harder. All right. Just make sure we have these memorized. All right. So I will see you guys tomorrow, and thank you for watching.